This question is about ionisation energies of group 2 elements. Explain why the first ionisation energy of the group 2 elements decreases down the group. So what we're needing to think about here is what is happening, what's the difference between the elements as we go down the group. And remembering that ionisation energy is the energy required to remove 1 mole of electrons from 1 mole of atoms in the gaseous state. And we're specifically talking about that outer electron. So as you go down the group, the outer electron is going to be further from the nucleus in a higher energy level because there is an increase in number of shells. So as you go down the group, the outer electron is further from the nucleus as there are more shells and there is more shielding. As a result of that, the nuclear attraction to the outer electron, so that is the attraction between the nucleus and the outer electron, is less, and less energy is needed. Give an equation including state symbols to represent the process that occurs when the third ionisation energy of magnesium is measured. So this is removing the third electron from magnesium, so it would become Mg3+. And remember, we do need state symbols. So if I was trying to remove the third electron, I must have started from the 2+ ion in order to remove the third electron. Explain why the third ionisation energy is much higher, so that's an important word there, than the second ionisation energy of magnesium. So if we think about the electron configuration of magnesium, we can see it ends in 3s2. So to remove the first electron, we'd be removing one of these 3s2, and then the second ionisation energy would remove the next 3s electron, so we'd remove all the 3s. But to remove the third electron, we're going to have to remove it from the 2p energy level, 2p subshell, or the second energy level, and that is much closer to the nucleus, and therefore less shielded and more energy is needed. So we need to say the third electron is being removed from the second energy level or second shell, which is closer to the nucleus with less shielding. More energy is needed. And the reason it's much more is because of this new shell close to the nucleus. Removing the second electron does require more energy, but not much more.